Hey, what's going on, guys? Let's try this problem right here. This question is asking determine if the following differential equations are homogeneous. If it's homogeneous, then solve. Now first of all, to see whether a differential equation is homogeneous, what we have to look at is we have to see this dy over dx is can be written as f of y over x. So we have to have a function in the right side. We have to have a function that can be written as y over x. Now let's see whether we can write this right side function in terms of y over x. And if you simplify this one, we can separate this one as two different functions like 3y square over x square plus xy over x square. So I just separated, right? The denominator is common. So I separated like this. Now here we can take this 3 common, and here we can write this one as y over x whole square, right? And the next one we have x over x square, so x and x square cancels each other, so we are going to have 1x here. So this is going to be y over x, and if you look at this one, this is a form of y over x. So in the right side function we have these functions in terms of y over x. So this means this is a homogeneous differential equation. Now we can go ahead and solve this problem, right? So after we find out this homogeneous differential equation, what we have to do is we have to equate this y over x value to v. So this y over x values are going to be just v, right? And also this dy over dx function, this function right here, that's going to be equal to this one, x dv over dx plus v. Now let's go ahead and write our new equation in terms of v and x. So dy over dx, as we see here, that's going to be equal to x dv over dx plus v. That is equal to 3 times. Instead of y over x, we replace that one with v. So this is going to be 3v square plus this is also y over x, so that's going to be equal to v, right? Now if you look at the left side and right side, we have plus v, right? So if you bring this v to the other side, that's going to be minus v. So v cancels. So here we can cancel these two v, and we are left with this one. And if you notice this one, this is separable. So now all we have to do is separate and integrate, right? So let's bring all the v's to the one side, and let's bring all the x to the other side and do the integration. So here we have dv over v square times 1 over 3, and in the other side we are going to have 1 over x dx. Now we have to integrate both sides. So if we integrate this side, we are going to have integration of 1 over 3. 1 over 3 is constant, so we can keep it this one in the front. 1 over 3, and v square can be written as v power minus 2 and dv. And in the other side we have integration of 1 over x dx. And if you integrate this one, we have to add 1 more to the power and divide by that power. So this is going to be v power minus 1 divided by minus 1. So we can put the minus sign in front, and this is going to be v power minus 1. So that can be written as 1 over v, right? So 1 over v, and then in the other side we are going to have ln of absolute value x. Also we have to put a constant. Now after we written this one, we have to write everything in terms of y and x, and we know that v is equal to y over x, so 1 over v is going to be equal to x over y, right? So this can be written as 1 minus 1 over 3 x over y is equal to ln x plus constant. And the final answer, we have to write this one in terms of y. So we have to rearrange this equation. Now let's move this minus 3 to the other side. So this is going to be xy, and if we bring this minus 1 over 3 to the other side, this is going to multiply by negative 3. So this is going to be negative 3 ln x minus 3c. So let's say c1 is equal to minus 3c. So we can put a c1 right here, right? Now since we are trying to find this one in terms of y, we can rearrange this one like y is equal to x over c1 minus 3 ln x. So this is the one we have, and it seems like, yeah, that's it. So this is going to be our general solution for this homogeneous differential equation. I hope you guys find this video helpful. See you next time.